You're squatting next to a fire. It's about 400,000 years ago, somewhere in northern Europe. The fire is dying, just a heap of black, cracked fragments glowing faintly. You reach in and grab one. It's hot, but not unbearable. It's light, much lighter than the branch it used to be. It's hard and black. You don't know what it is. You don't know you're holding almost pure carbon. You just know that when you blow on it, it glows brighter than wood ever did. That was the first time a human noticed charcoal, and that single observation would eventually allow our descendants to melt rock, forge weapons, and paint images that survive for tens of thousands of years. But here's the thing. Charcoal wasn't invented. It was noticed. It was a byproduct of every campfire ever built, sitting in the ashes, waiting for someone to pay attention. And someone did. We know this because of what they drew with it. 36,000 years ago, in a cave in France, humans were using charcoal to create sophisticated drawings of horses and lions. It wasn't just smeared, it was controlled, deliberate art. Charcoal made a mark, and marks made memory. The first recorded history was written in burnt wood. But that's just the beginning. The real game changer happened when we realized charcoal burns much hotter than wood. A wood fire reaches about 300 degrees Celsius. Charcoal, with enough air, can hit 700. With a bellows, you can push past 1,100 degrees. At that temperature, something impossible with wood happens. Rock melts. That green-tinged rock your ancestors used as pigment suddenly turned into liquid copper. That one chemical reaction, carbon stripping oxygen from rock, is the foundation of the Bronze Age, the Iron Age, and every piece of metal you've ever touched. For thousands of years, every gram of metal on Earth was smelted using charcoal. It powered the Bronze Age, the Iron Age, and even the creation of legendary steel like Damascus steel. Charcoal was the fuel. But there was a huge problem. Charcoal requires wood. Enormous quantities of wood. To make 1 kilogram of charcoal, you need 4 to 7 kilograms of wood. A single smelting operation could consume entire forests. By the late 1500s, England's forests were disappearing. The Royal Navy needed oak for ships. The iron industry needed wood for charcoal. They couldn't both have it, so, desperate, they turned to something else. Coal, a rock that had been known for thousands of years but was mostly ignored. The word coal didn't even originally mean the rock. In Old English, it meant glowing ember, which is what we call charcoal. The rock was called sea coal because it washed up on beaches, or pit coal because it came from pits. The language tells you which fuel came first. But when did we first actually use the mineral coal? The Romans were burning it in Britain nearly 2,000 years ago to heat their baths. The Chinese were mining it at an industrial scale for iron smelting during the Han Dynasty. The Hopi people in Arizona were using it by 1000 AD. These were all independent discoveries because coal outcrops exist everywhere. If you have fire and a black rock that burns, you'll figure it out. Now, here's the part that's genuinely unsettling. The coal you burn today is not just old, it is ancient beyond comprehension. It formed during the Carboniferous period, about 300 million years ago. That coal under your feet is over 1,000 times older than your entire species. Back then, Earth was covered in giant swamps. Trees grew to 40 meters tall, but when they fell, something extraordinary didn't happen. They didn't rot. The fungi that break down wood today hadn't evolved yet, so tree after tree just piled up, layer after layer, for millions of years. Compressed by sediment, heated by the Earth's crust, that unrotted wood slowly transformed into peat, then lignite, then the coal we dig up today. When you burn coal, you are releasing sunlight that was captured by a tree 300 million years ago. You are, in a very real sense, burning ancient sunshine. So, medieval England is running out of trees. They turn to coal. But here's the problem. Coal contains sulfur, and sulfur ruins iron. When you smelt iron with charcoal, you get clean metal. With raw coal, the sulfur makes it brittle. For centuries, this meant coal could heat your home but couldn't make your weapons or tools. The solution came in 1709. A man named Abraham Darby figured out how to make coke. It's the same process you use to make charcoal from wood. You heat the coal to drive off the impurities, including the sulfur. What's left is a purified fuel. Darby used it to smelt iron. That iron built steam engines. Those steam engines pumped water from coal mines, so more coal could be dug, so more iron could be made. The Industrial Revolution was a feedback loop. Coal made iron made engines, engines mined coal. The Industrial Revolution wasn't just powered by human genius. It was powered by a 300-million-year-old chemical accident. Humans reached into the past, grabbed that ancient sunlight, and spent it all in 200 years. But burning that account came with a terrible cost. On December 5, 1952, cold air trapped London's pollution. For 5 days, the city was smothered in a yellow-black smog. Theaters closed. Ambulances stopped. The Great Smog of London killed an estimated 12,000 people. And before the smog, there were the people who dug it out of the ground. Coal mining is one of the most dangerous jobs in history. Explosive methane gas seeped from seams. In 1842, a royal commission published testimony that shocked the world. 8-year-old children worked in total darkness, opening and closing ventilation doors for 12 hours a day. The Mines and Collieries Act of 1842 banned girls and boys under 10 from underground work. But before we vilify coal forever, we have to remember where it came from. Charcoal and coal are the same thing. Chemically, they are both concentrated carbon. One is carbon from a tree that was recently alive. The other is carbon from a tree that lived 300 million years ago. One is fresh, the other is ancient, but the chemistry is identical. Carbon plus oxygen equals carbon dioxide, heat, and energy. That equation drove every bronze sword, every iron plow, and every steam engine that built our world. It also created the problem we're facing now. And here's the last, strangest chapter. Coal tar, the thick, foul-smelling goo that's a byproduct of making fuel, was once considered useless waste. In 1856, a young chemistry student named William Perkin accidentally turned it into the world's first synthetic dye. From that same coal tar came carbolic acid, the first antiseptic, and even the precursors to aspirin. The waste product of making fuel became the foundation of the modern chemical industry. Even now, the story isn't over. A fire has been burning under the ghost town of Centralia, Pennsylvania since 1962. Scientists estimate it could burn for another 250 years. And in Australia, a coal seam has been smoldering for 6,000 years. That fire was burning when the pyramids were being built. So, how did we discover charcoal and coal? The answer is that we kept discovering them, over and over, on every continent. Charcoal wasn't a single invention. It was a rolling series of realizations that this one byproduct could do more than anyone imagined. Coal wasn't adopted because it was better. It was adopted because we ran out of trees. The first time a human picked up a piece of charcoal, it was warm and it glowed. They had no idea they were holding the key to our future. They just knew it burned. And they are still burning it now.